Hey guys, today we're going to talk about the first degree AV block. The first thing that we need to know about the first degree AV block is there is a delay in the transmission of sinus impulses to the ventricle. And remember, with all AV blocks, the area of the heart that is affected is the AV node or possibly the bundle branches. So in this area of the heart, this is where we're going to see that delay. The impulses still originate in the SA node and they travel through the interatrial tracts down through the atrium. They go through the internodal tracts, but when they get to the AV node or either the bundle branches, they slow down. So with the first degree AV block, there is only a delay. With that being said, what we need to know about that is with a delay, all of the impulses that are initiated here make it through the AV node and through the bundle branches, but they make it through at a slower pace. So the end result is the electrical activity makes it to the ventricles, but they make it to the ventricles slower. There are no impulses that are dropped off or lost here. All of them make it through. So when we look at an AV block, the first thing that we're going to look at on the rhythm strip is the PR interval. So to determine if a person has an AV block, we look here on the strip. The PR interval is this area that appears in red right here. The normal PR interval is 0.12 to 0.20 seconds. If you see a lengthened PR interval, which is anything greater than 0.20 seconds, you can expect that we are dealing with some type of a heart block. So when we're talking about heart blocks, this is the area on the strip that we're going to first look at. So going back to a first degree AV block, we know that the PR interval in a first degree AV block is prolonged, okay? And this is a result of that delay that occurs in the AV nodes. In the AV nodes are either the bundle branches. So that area of the heart slows the impulses down, and it slows it down at a greater, it slows it down and makes it go slower than it would normally go through there. So that's why we see the lengthened PR interval. There's many causes of a first degree AV block. That area in the heart could be ischemic, meaning there could be a coronary blockage obstructing blood flow and it's not getting the oxygen that it needs. So the heart tissue in that area of the heart could be dying, and that could cause malfunctions in the electrical pathway. So that's one cause of an AV block. But just know that in the first degree AV block, the site of the block occurs in the AV node. So going back up, with a first degree AV block, the AV node is actually the site of the first degree block. We had mentioned that blocks can occur in the bundle branches, and they still can, but in a first degree AV block, the site occurs here in the AV node. And in the first degree heart block, it's characterized by that prolonged PR interval. So looking back at the strip here, one of the characteristics of a first degree AV block is this interval is going to be lengthened. It's going to be greater than 0.20. Moving forward, let's look at the first degree AV block. The first degree AV block, it can occur at any heart rate. The regularity really depends on the underlying rhythm. However, the P waves are upright, matching, and there's one P wave per every QRS. So going back to this rhythm, the P wave here is upright and matching, and you're going to have a P wave in front of every QRS that you see. And the reason you will always have a QRS that follows the P wave is because in a first degree block, there's only a delay. All impulses get through, and because all impulses are able to get through, a QRS is written because the ventricles will contract. And so moving forward, let's continue to look at the first degree AV block. Again, we know that PR interval is greater than 0.20 seconds, and it's constant. It doesn't change from segment to segment. So going back to this strip, you can look at this PR interval, and if it's greater than 0.20, it's going to be greater on the next leg down. So it's the same here as it is here as it is here. So you do not see a change between the different cycles. So that should, they don't lengthen and they don't get longer. These are constant throughout the strip with each one. So that is also something that you need to look at when we're looking at a first degree AV block. They're prolonged, but at the same time, they're constant. The QRS complex in an AV block is less than 0.12 seconds. And the reason it is less than 0.12 seconds is because with a first degree AV block, the ventricles are not really affected. They are still able to fire, and they're firing from the normal pathway of electricity that is generated in the SA node. Moving forward, let's talk about the different causes of the first degree AV block. The cause of an first degree AV block can be AV node ischemia. It can be digitalis toxicity or medication side effects. The first degree AV block is seen only with rhythms originating in the sinus node. So always remember that a first degree AV block has to come from a rhythm that is originated up here in the sinus node. If a lower pacemaker takes over, if the AV node or the ventricles take over as the pacemaker, you're not going to see a first degree AV block, because a first degree AV block happens in this area because this impulse that's originated here is slowed down. So if the lower pacemaker, if this pacemaker or the ventricles take over, you're not going to see a first degree AV block, because you're not going to have a P wave painted on the EKG strip to measure an accurate PR interval. Let's look at the adverse effects of a first degree AV block. There's really no symptoms with a first degree AV block. The treatment of this, you're going to remove the cause and you're going to treat the cause. So the big thing here is to remember with a first degree AV block, whatever the cause may be, we need to remove it. So let's go down and let's look at this strip here. And this is a first degree AV block. If you look at this strip here, let's start here. We have a pretty little P wave, and then we're going to count our PR interval. We have 1, 2, 3, 4, 5, 6. Okay, so there's 6 little blocks at that PR interval. There's 1, 2, 3, 4, 5. It appears to be 6 here. There's 1, 2, 3, 4, 5, 6. Okay, so there's 6 little blocks on this PR interval. If we take 6 and multiply 6 times 0.04, that gives us 0.24. 0.24 is greater than 0.20, so we automatically know we're dealing with a first degree AV block, because these PR intervals are constant from here to here to here to here, and they're followed by a QRS. We did not lose any of our QRSs anywhere on this strip. So we're simply looking at a delay in the electrical conduction, which you see here by the extended PR interval. I hope this helps, and if you have any questions, please see me.